Ma'am, you are live now. Please start.
Thank you. Hello, and very good evening, all of you, and welcome to the session 3 of the discussion forum of NPTEL course in Pharmacognosy and Phytochemistry. I'm Galvina Pereira, your course instructor, and I'm here for the session 3, that is our doubt solving session, just a week before your examinations. So feel free to raise any queries, anything that came across your mind, and anything that you wish to know about this course that you have interacted through this 12 weeks. So please let us know our difficulties, or please let us know our limitations so that can help us improve as well. We're just waiting for the questions from your end. So just requesting you to drop in your queries into the chat box of the YouTube live streaming tab. Now, meanwhile, our sessions are going on. We'll just brush in through few questions that have been raised on the discussion forum. So we just visit the discussion forum and check all questions that are there from our avid learners. We'll try to sort a few. What we can see is again majority of the questions are pertaining to the study material. Now this since this is the first run of our course, we've been not able to provide a very elaborative course study material, but what we have is our presentations and some transcripts that we'll be uploading. But more appropriate is what we have in our hand as textbooks in pharmacognosy. So I suggest rather than relying exclusively on the content, you can even go a step further into reading textbooks of pharmacognosy, like Pharmacognosy by Trees and Events, Pharmacognosy by Viren Shah, and there are few additional books by Wallace Bruniton that can also help you with the phytochemical part of that. So we'll be sharing the URL to those textbooks, but not exclusively the notes per se in this run of course. So we have a first question that what tests can we do to evaluate piperine and other phytoconstituents? Now, piperine is one of the constituent that you have studied during the course of alkaloids. So piperine is an example of a amide containing alkaloidal derivative which is very neutral in nature because of its amide linkage. So a better way to test for alkaloids in your piperine is what you can do is you can just take an alcoholic extract and treat it with any of the alkaloidal reagents if you recollect, like your Dragon-Doff's reagent, Wegener's reagent, or Meyer's reagent, as well as your picric acid, and you might find a little amount of precipitate corresponding to that. Like with Dragon-Doff, you might come across an orange red precipitate. Similarly, in your Mayer's, a whitish color precipitate. For your Hager's, that's your picric acid solution, you might come across a white color precipitate. Now, in addition to that, a more specific way to do or to analyze piperine is to carry out a thin layer chromatography. So we saw in our subsequent weeks in the quality control methods, you could run a thin layer chromatography. Now, to decide the mobile phase, you have numerous literature. You can just Google in and find out few research articles. Different articles will give you different mobile phases, but every mobile phase will have a specific RF, that is retention factor. So you can do check the retention factor of that, and then maybe dip your plate in Dragon reagent to get a orangish color spot. And if that matches the RF, you're sure you have purified your piperine. So does that answer the query to your piperine? Now, the other part of the question is piperine and other phytoconstituents. In this case, you will have to exclusively tell me that what phytoconstituents you are looking for. So, you remember when we did quality control, we saw that we could do the phytochemical analysis. So if these compounds are present in a good quantity, they will be able to answer the phytochemical test. Say, for example, phytochemical test for flavonoids, phytochemical test for terpenes, especially those which are present in volatile oils of that. So in that case, you could do those specific tests provided the phytoconstituents are present to that level. In some cases that they are present in the trace amount, a more specific method like your chromatography, your HPLC, HPTLC, or in case of volatiles, even your gas chromatography can help you analyze the trace levels or minute quantities of your phytoconstituents. Malati, with regards to the last days of studies, what I suggest is if you see the phytochemicals, now this is like a short key, but I'll not be like very elaborative here. To the point, the syllabus just moves in three parts. The first part is the phytochemical part and the biosynthetic part. The second part is the quality control part, and third is the computational part. So when you're focusing on the pharmacognosy subject per se, you have a phytochemical scheme, and this scheme focuses on few points like what is the source, the botanical source, what is the compounds present in it, how do you identify this compound, and where they apply. And the next point is how are they biosynthesized. So for every drug, if you know somehow you can prepare a table of this few key points, you are really prepared for the majority part. Like almost the first 9 weeks go into what is this drug, where is it obtained from, then what are the phytoconstituents contained in it? How do you analyze those phytoconstituents? Which classes phytoconstituents belong to? This is basically the chapter head. And the applications. How are they biosynthesized is done in the first unit. Now, the second part of it is more to do with quality control techniques. So you just roughly kind of take a guess based on this first 9 weeks, which phytoconstituent can be analyzed by which method. And last, computational is just to make you acquainted with the softwares, like which software work for which. If you get the knack of it, you are very comfortable for your examination. So I hope that gives you a key to studying well in the examination. So all the best for it. I guess it's on 1st November for all of you. We'll just await few more questions from your end. Now, meanwhile, we'll just take a question from a forum. We had a query on particularly what are coumarins. So coumarins are basically phenylpropanoidal compounds having a benzopyra or rather pyrone kind of nucleus, so it forms a lactone. It has ability to fluorescence, and there are certain drugs such as your safatida, which gave you fluorescence because of the umbelliferone that was formed. So it has a ability to glow or the ability to fluoresce. So this compounds or cyclized derivatives of phenylpropanoid C6C3, which form lipoization, thereafter converting into a benzopyrone nucleus, are called as your coumarids. And whenever you take alcoholic extracts of this plant, majority of the time they do have a good ability to flourish. Now there is a few more queries on were there any books available for anatomical identification. Now, we saw a few softwares, and the softwares gave you nice botanical or herbarium descriptions. Now, this herbarium descriptions many a time are useful for botanists in order to take a gauge of the flower size, the shape, or even in some cases, traces of colors, appearances, and so on. Now, when it comes to anatomical identification, there are a few ones, but they are not very elaborate. They are still building on, but we've suggested a few books. That is one by Mr. Dr. Jackman, that is your Atlas of Microscopy, and another is by Dr. Malathi. It's the microscopic profile of drugs. Now, if you see both of them have a very elaborative detail of botany. And if you go to Dr. Malti Chauhan's book, her every volume is one part. Like one volume deals only with bark drug. So imagine comparing 50 bark drugs with each other. The characteristics are very identifiable and to core. That means they have been taken the way they have been seen. So that gives you a very accurate information of that. So you can do or you can search for these two books and you will get a good detail about the botanical description of your drugs as well. Okay. Now, Alexander's asking how many questions. So, Alexander, just to help you out, you will be having a MCQ type. It's not a descriptive type. So, you will be having a MCQ type of examination with 100 questions. So, you just have a choice of maybe four. You have to pick one, and that is how it is. So, a 3-hour test of 100 questions, MCQs. If somebody got failed in the written examination, so these are little exam centric. Can they give a re-examination? I think a re-exam attempt is possible after a re-registration and repayment of examination fees. Uh, Somebody is worried about negative marking as well. So NPTEL examinations currently don't have any negative markings per se. But yes, wrong answer definitely means 0 marks. The right answer means a 1, and then that's converted into a score of 70, and your internals are converted into score of 30. That's how it goes. So the number of questions is 100, but your internal and external scores are then sorted out. External as 70 and internals as 30. Now moving to the next questions from the forum. Similarly to your anatomical identification, are there any databases for thin layer chromatography? Now, thin layer chromatography is a very dynamic system of chromatography. So, say for example, you're using methanol chloroform, 9:1. So, 9 times methanol, 1 times chloroform, you will have a particular retention factor. But if you change it to 8 times methanol and 2 times chloroform, your RF is going to change. So every time, even a slight change in solvent is going to change the RF. So that is the reason there's nothing like an encyclopedia per se. However, there are certain reference books which are using standardized mobile phase, which stand true to most of the classes of phytoconstituent. One such book is Plant Drug Analysis by Wagner, and another book that I have come across is very reliable is your Indian Pharmacopoeia. The next set of books is your ICMR monographs that also give you a very kind of very reliable mobile phases with a very reproducible RF values. So my answer to this is Plant Drug Analysis by Wagner. Then you go by your Indian Pharmacopoeia. especially the herbal monograph, that is the green part of, or the green section of the Indian Pharmacopoeia, volume 2. And thereafter, your ICMR monographs, which also have a TLC, which is well validated. Now, the next question from our forum is, does a breakdown of larger tannins, that is true tannins or especially hydrolyzable tannins, lead to pseudotannins? Yes, the answer is correct. So imagine you have a tannin. Tannin basically are polymers, and imagine a polymer made up of gallic acid, say 10 gallic acid, or we even saw your tannic acid, which was a glucose in center surrounded by 6 gallic acid. Now, when they are subjected to hydrolysis by enzymes such as tannase, strong acidic or strong basic conditions or extremes of pH, the ester linkages get hydrolyzed. Now, there are some ester linkages, there are some ether linkages also you might come across, but majority of them in tannins will be ester linkages, and you will find that the conditions for hydrolysis are relatively mild. And when they get hydrolyzed, you will have monomeric gallic acid, monomeric ellagic acid. So this monomeric forms are often addressed to as pseudotannins. The reason is when they are in large molecular weight range, they have a ability to bind to protein as a big molecule. And when they are binding to a protein as a big molecule, the other side of molecule is also available to chelate with metal ions, which are often addressed to as mordants. So remember in your gold meter test, your ferrous sulfate was used as mordant. Now this ferrous sulfate will get chelated between the carboxylic acid. Now you just imagine a single molecule of gallic acid is there that will bind to your protein. There is no COH available for chelation. So that has no ability to bind and tan or as well as darken the skin as well. So as a result, they are called as your pseudotannins. So true tannins are high molecular weight, which in which hydrolyzable tannins are generally linked by ester linkages. They will get hydrolyzed, converted into a small molecules like your gallic ellagic acid, which will lose their ability to tan the animal hide, and as a result, they will be called as pseudotannins. So your reference to that sentence is correct. The next question by Aman is, can India also become a biological source of grape peel? Sure, Aman. I mean, India is, and a lot of grape peel extracts have been taken from the Indian subcontinent as well. So, yes, the answer to that is yes. We can have abundant grape peel, especially the purple ones. But if you see the anthocyanin rich ones, which is referred to as the Concord variety, those varieties are more of your European varieties. So if you compare your Indian wine grapes, which are purplish black in color, versus the European as well as the American variant. Anthocyanin contents in the American European variants are much higher, and for their antioxidant activity, the anthocyanin content is measured. So they are far more superior than the Indian variant. But in terms of source, yes, we can also supply. And for us, rather than importing, this can be cheaper. And if that is not a very dose sensitive issue, you can consume that as well. Okay. Um, Shiba is asking, can you suggest a book for antioxidant essays? Shiba, rather than a book, you can read a lot of papers or research articles wherein you have a journal on antioxidants. So there are different type of antioxidant essays depending upon how they perform. Look, mechanism of antioxidant assay not it does not always remain same for all type of molecules. Definitely it's redox, but imagine some of them are going to be polar, some of them are going to be lipophilic, like non-polar, and as a result, they might require a slightly different conditions, slightly different assays Now, if you want to mimic those antioxidant conditions in our body, you might need to perform as a one specific pH. So, if you go across this journal called as antioxidants, you might come across, 10, 12 methods to perform antioxidant assay. Now, the common one is DPPH and fallen CO-Cal2 method. But apart from that, there are many other methods which are also there for your lipophilic compounds. Now, the next part of your question is apart from antioxidant assays, phytochemical content evaluation. Now, when we did our quality control, especially when we started from our week 10 onwards, we saw that we could do total phenol content, total tannin content, total alkaloidal content. So, there are simple colorimetric methods which can be done. So, for steroids, you can use a Lieberman-Bouchard method. For alkaloids, you can use like a bile green salt, or even your Dragon by gravimetry method, or for flavonoids, you can do a ALCL3 based methods. So all of these methods are there, and that can help you determine one particular class of compound. So flavonoids totally can be determined by ALCL3. But in the mixture of flavonoids, if I have to specifically determine one, in that case, my chromatographic methods like your HPLC or HPTLC methods are more specific there. So books, rather than books, Shiba, I would suggest that research articles are more relevant. Again, in the research articles, sometimes the method they give elaborately. Some research articles, I do agree, just give a citation to the previous paper, do not give the method, but just search or cross-site that article. You might come across a more reliable method for, or more recent and apt method for your antioxidant essays. Now, the paper will not have a grade system or a percentage system. It's more to do with the marking system. So it has, when I say 70 marks, so it's your 100 marks is going to get converted into 70 marks, and your internal is going to get converted into 30. So 70 plus 30 is overall 100, and that's why we call it as percentage marks. So that's how your score is going to be graded. Uh, Abhi is asking it is going to be a CBT mode or paper pen. It's going to be a completely online test, Abhi. So you just need to go to your centers, which are there on your admit cards, which you downloaded from the NPTEL website. Just refer to that, go to those centers, and those that centers you just have to click on your username, password. Once you log in, the MCQs will start appearing. So you all just have to click and to move on to others. So it's just an MCQ online computer-based test. So it's a CBT. So what about week 12? Now week 12 is what we have learned over and above that. Instead of memorizing, what are softwares helping out with? So from exam perspective, if you're asking the week 12, it's more of then which software can be used where and which and how it is applied. That is how you're supposed to know for week 12. Hmm. If somebody is stuck with the hall ticket or document verification, I think this discussion forum is not for them, but I hope you just mail it to the support mail that the NPTEL team has got it and get it rectified quickly because the exam's coming on this Sunday. Okay. Now, again, certificate is again issued only after your clearing of examinations. So all the questions on the forum that are being asked, that is discussion forum, we've been able to answer. So just taking questions from your end from the YouTube chat. So I'm not able to get the question for TBR. The passing percentage, I think just see the NPTEL guidelines for it. They'll be more clear with the cutoff for the internal and cutoff for the end sem or what is there. I think you to clarify, get cleared in both. Only when you clear in internals, you get to appear for the end sem. And just check the NPTEL guidelines. I think they're 50%. Any queries on the technical content? Because I think the exam guidelines, you will be properly getting them from the NPTEL examination guidelines. And that is what you should refer to. And so that you're very well aware of what you're appearing for. In terms of technical queries, any other questions that you have or any other difficulties that you have come across while going through any of the sessions, please feel free to, jot it down. We can help you with that. Is agar a gum or a mucilage? Agar is actually obtained from a sea kelp, and what when you see when you have a sea kelp, many of them are sulfate containing. So if you see your agaros, agaropectin, they are all sulfate rich and they are classified under mucilages. So agar is an example of a mucilage containing drug. Whereas your acacia and tragacanth are gums, they are more uronic acids and not sulfate. So acacia tragacanth, you put it as gums, whereas your agar, alginates, and your carrageenans are examples of mucilages. They are physiologically present. And whereas if you remember your acacia tragacanth, they have to be logically be present. That's another difference between your gums and mucilages. So gums are logical product, whereas your mucilages are physiologically present. Even your chia seeds or your bhindi, all of them are mucilages. And when you stain them with ruthenium red, they'll all become red because of the presence of sulfates, and that's a unique feature of your mucilages. That doesn't happen with gums. Unfortunately, this is the first run of this course, and as a result, there'll be no previous papers for this course. But maybe, the same thing, what you can do is you can just check for your assignments of all the weeks and you get a brief, like overview what type of questions you can anticipate. What questions you have attempted in the course so far, the remainder questions will be on very much the similar lines. So even in the pattern of examination, it's going to be very much same of those MCQs that you had in your assignments. A very similar type of 100 questions is all you're anticipating this weekend. All the best. Yeah, Swapnil, what you can do is you can check the institute website, Institute of Chemical Technology, Mumbai, and you could have my email address from there. Definitely, I'll help you out in your project. So, Alexander, your question is if alkaloids are alkaline. Now, to that statement, let me just say majority of alkaloids are alkaline, but not all. So there are exceptions. A very good exception is your piperine itself, where the nitrogen group is involved in amide formation. And amide is going to give you more of a neutral group. So yes, majority of alkaloids, take for example your nicotine, atropine, those are all very alkaline kind of alkaloids, including your quinine part, your piperine and other compounds. There are some compounds which are even slightly towards the acidic side, like your noscapine, which have an acidic moiety as well. And what effect they will be having when substances are high in free fatty acids. Now, for alkaloids, the polarity, when they are amine in nature, if you are treating them, now there's a method called as STAS auto method. If you're treating them by basification, now this alkaline compounds are present as salts. Say, for example, quinine is a salt with quinic acid. Let's then put them together. Okay. And what is going to happen is if you I treat it with the base, my quinic acid is going to get dislodged. And now my quinine is a free base. Now their solubility increases in this free fatty acids when I have something more alkaline than my alkaloids. So their solubility is increasing. On the flip side, instead of adding more alkaline, if I add something which is more acidic, this alkaloids get converted into stronger salts and their solubility into this free fatty acids will decrease. So much so that earlier when quinine was being purified from cinchona, people used to add just tuna or lime to quinine and then they used to extract it in a mineral oil, what we refer to as solar oil. So even mineral oils were good enough to extract those lipophilic free bases. So same thing can be done with your free fatty acids. They'll become very good solvents. So even if you melt them off at a little temperature, all your alkaloids will get solubilized in your free fatty acids. Does that answer it, Alexander, for you? So we'll just wait for another some time till we have any more questions. So just about week 12, let me tell you that I have discussed a few website or servers that came across with the NMR, with the spectroscopic data, with the phytochemical constituent, but those are not all. There are many URLs which have more elaborative data sets. Some of them are paid, unfortunately, and that's the reason we didn't discuss those. Some of them are freewares, but yeah, many of them are almost equivalent when their content was compared. So we just tried to give you best examples of such servers. But if you search on the net, you might come across many such servers who can help you in phytochemical search, plant search, analysis, as well as the what is called as the spectroscopy and pharmacologic estimation of your compounds. Now, with the AI coming in, there's still more advances happening on day-to-day basis. So just keep on checking, just randomly Google databases to predict pharmacology, databases to predict ADME, and you'll get many of them. So just wait for another 2-3 minutes if there are any more questions from your end. PDF notes per se is a little difficult right now, but what I suggest is you can just quickly browse through the textbooks. Now, many of this textbook PDF are freely available online. I think trees and events, Berecha, many of those PDFs are available. And if you just, like go to the particular chapter, like carotenoids, alkaloids, you will have a very seamless or similar content therein. So those are kind of notes. What I suggest is in those chapters, you pick up only the drugs that we have discussed. Owing to the constraint of time, don't go on elaborate reading. Just currently refrain or restrict yourself only to the details that we have discussed in this course. But for your knowledge, thereafter, you can refer to the whole textbook as well. Alexander, that's a good question. Not really pertaining to this course, but yes. Now, there are certain herbs in Ayurveda which is said to be heating or cooling in Ayurveda and definitely in Chinese medicine also. Now, I'm not really a practitioner of Ayurveda, but just to what I can correlate in terms of phytochemistry, yes, there are phytochemicals which trigger the feeling of heat. So, if you can say the pungency. So there are some phytochemicals which are more pungent and which are known to aggravate body heat, increase the rate of metabolism, and that is how do you see it. And in some cases, there are certain phytoconstituents. Now, a good example would be your piperine, capsaicin, and so on. On the flip side, there are also compounds which are known to have cooling effect on our body. So, say for example, you have your asafoetida, which is known to have a coolant effect on our body. So yes, maybe the phytoconstituents of asafoetida, if you go by seeing those few small molecular weight tannins or acids or flavonoids associated with it. But the clear route is not established because Ayurveda works by a very different mechanism, and so does modern cognosy. So the link as of now has not been established very clearly and pharmacologically with clinical trials saying yes, this is the compound which can give you or increase your metabolism, increase your body heat, and this is the compound which can decrease the body heat and give the cooling action. But yes, there are herbs prescribed in Ayurveda which are generally thought to be more pungent, spicy, which are more to increase the body heat, whereas there are also coolants which are more sweet or mellowed down, and they are known to give you cooling effect. One good example is your hing. So you can maybe have some correlation, but a clinical proof is not established of them. Whereas if you go to see the Chinese system of medicine, the Chinese have gone very much overboard with their system of medicine, and many of them have what they call it as the heat and cool, they refer to as yin and yang. So they have yin herbs, they have yang herbs, and they have gone, if you read certain research articles, that which compound in this herb is really clinically responsible for this activity. So rather than Ayurveda, I think you refer to Chinese traditional medicine, there you will get more phytochemical references as compared to Ayurvedic medicines. Now, why this effect is associated right now, I cannot clinically say because it's not proven, but computationally, they do say that it's more to do with the receptor interactions, heat generation, enzyme activation is what they postulate the mechanisms to be. Pleasure's mind, Alexander. So definitely, again, you can connect to me on my email at Institute of Chemical Technology. Just go through it and you'll come across my profile where you'll get my contact details. Any more questions from the audience end? Sure, then we close the session for the course. Wishing you all the best for your examination, a great learning experience. Don't forget to dwell on this subject further as we bring in new courses into this, as well as refer to the textbooks to enrich your more knowledge on this subject. So, thank you, everyone. Have a pleasant evening and wishing you all the success in pharmacognosy and phytochemistry examination. Have a great day ahead. Thank you.
Okay, thank you, ma'am.
Thank you.